Correct.
Voilà, meeting de listage. Opérativement décoratif.
Lole, ahí con ya aparelho de
Bonjour. Are you able to get me?
Eu vou começar por trás. Quase.
Je n'ai rien attendu.
We're able to get you.
Okay. 23. Kaweza, ça va? Ruben there. Benzo.
Ça va, monsieur?
Ça va, Ruben. Benzo, ça va?
Oui, ça va.
Je vais bien.
Benzo na Monsieur Harold. Okay. Bon. We're going to start. I hope you're able to see l'écran. Voila. I don't know if we have any questions from the previous TD that we had. Sinon, on va commencer. Now, like I said last time, that this is the most, actually, one of the most important say that you should miss. And when it comes to suites, it's very, very important, very, very vital, because everything that we do today, the next time you get to learn these things is actually when you go to your schools. So if at all is somewhere where you don't understand, s'il vous plaît, don't hesitate to ask me. I'll be very, very slow. And of course, if you have internet problems, I don't know how you're going to manage to fix it, because the questions for today are very, very like bulk. They're calculating the more of calculating these numbers. So I won't manage to explain, then somebody comes and says start from one. I won't be moving fast like that. So I'll be explaining step by step. If you don't understand the point, just tell me that, hey, just tell me to stop, and then I'll be able to explain. Okay, est-ce que c'est clair? C'est clair, n'est-ce pas?
Oui.
Oh. Alors, il faut dire, are you already tired? If you're tired, you can postpone the I want you guys to be fresh, huh?
Mr. Ernest,
Oui?
I think you forgot to send the copy of the last TD, what we did in the group.
Sorry. I think I forgot. Wow. I'll need to find that paper where I wrote the answers. Bon, I'll do that just immediately after the TD. Okay, pardon moi, s'il vous plaît.
All right, thank you.
Okay, you're welcome. Okay. So like I was saying, if you guys are tired, just tell me. Quand vous êtes fatigué, vous juste me dire. I've done a lot of things with you already. And bon, I also received your complaint. You said no. I've been doing a lot of questions, doing a lot of analysis. Actually, it was actually just my part of sacrifice. Like I told you last time, that for you to get to be, you guys were complaining more on analysis, so I had to make sure that I put you in the system. Okay, so if you observed last week, we had like 2 lessons, or this week actually we had like 2 lessons or 3 lessons for analysis. So I did that for you guys to get into the system, and that won't continue up to the 15th, because after the 15th I'll be very, very occupied, meaning that I'm just going to be meeting you once in a week. So from this week up to the 15th, if at all you're not already in the system, it's going to be difficult for you to get there. Okay, it's going to be very, very difficult for you to get there, because we have done a lot of stuff right now. Even if I was to let you go to your school, trust me, you can validate analysis. Of course, that is if you have been on the same page. Sinon, ça sera la même chose. C'est juste pour... Oh. Ok. Is Linda there? Linda? Est-ce que Linda est là? Linda is not present? Ok. D'accord. Donc, on va commencer. So the first question that we are having is, we consider a suite. Ah bon, avant je commence. Mono did with your suite géométrique and suite arithmétique, n'est-ce pas?
I thought she had texted you something. Haven't you read the text?
Attends, what she text me? She told me, okay, I think she told me she's done some part, unless if there are things that I need to go into details. That's what she told me, n'est-ce pas? I'm not mistaken.
She said that she didn't do things, she didn't explain like on a deeper level. She said that you are going to do that.
Yeah, she said, when we doing lesson about suite arithmetic, geometric, I did the base. Bon, yeah, only the base. I wanted you just guys to get the base. That's just the most important. That's what we're actually going to use. So as long as you did the base, c'est bon. Okay. Yeah, I sent that to teach you the base. That's the only thing that we normally use. So she probably showed you the formula for suite arithmetic and suite geometric. That's the only thing that I want. And the same thing that you used to do in that, where you have 1 plus 2 plus 3, you find the common. Same thing. If she explained that, that's excellent. Okay, so start. Switch UN where n belongs to numbers.
Ernest, you're
This is
breaking.
defined
We
by
can't hear you.
0 as the first.
We can't get you, Ernest.
1 plus
Your voice is
1.
breaking.
Simplest question of this
I'm not really sure if it's just my network, but his voice is breaking.
It's not just yours.
Okay. Oh la la. Chikoti Joshua, you're now the host, so you need to allow me to share the screen. Chikoti Joshua, est-ce que tu es là? Joshua. Oui, Joshua. can't get you, Joshua. I can't get you.
I think Joshua's left.
Boy, he's
Yeah, now the
showing here.
host.
All right. Okay. Okay, merci. Okay. Bon. Okay, so we continue. I had internet problem. So is equal to no, I don't know what's going on with Manipur today. Yeah, it's really giving me problems. So like I was saying, what's the first thing that comes? So that I can see my screen. It's very bad today. No wonder I like doing lessons at night because of my network. Huh? Yeah, my network is seriously, but normally it's bad during the day. I hope you're able to get me though. Are you able to get me?
Yeah, I'm good.
Yeah.
Yeah. I was saying normally no wonder I like conducting my lessons at night because during the day my network is very, very bad. Warrior Kaunda, can you make me the host?
Okay, let me try. And then I said we should have the class at night. I'm an Adventist, so I can't have it unless we have it on Sunday at night. Now Sunday is tricky because we're also having another lesson on Sunday.
Night. And today we have Champions League. We have another lesson on Sunday.
Yes, Sunday, another lesson.
At what time?
17 or 16.
Yeah, 17, 16, something.
Mine even start.
On Sunday, some of us have class for chemistry with Jacob, so we can.
Yes, that's true. So spare us, please. As in, if we don't try today, then it will be bad for us on Sunday.
And we can't do it.
Let's do it on Monday.
Yes, I think maybe Monday can do because
Yes,
Sunday,
Monday.
not Sunday.
Sunday is okay.
Monday.
Sechigadfunza kadu.
Imagine that the fine looking shawty buying fake cosmetics from the street.
Vai sair. Vai sair, man. What account up to now? You didn't manage?
No, I'm having connection problems too.
Bon, okay. If I try to partager comme ça, is it giving you anything like allow NS to participate? I mean, just some to participate. To partager l'écran?
No.
I told you, let's just have class at night. You people are confusing me. Bon.
No.
Night, no.
Are you saying today night?
No, not tonight. Tonight is UEFA Champions League. How can you have class when Madrid?
Imagine.
Yeah.
Bosses, majority have voted Monday. I think Monday.
We can have class. Madrid aluza lero.
Yeah, what's over no kamba?
Monday Ninde is coming to play football, you know, at this. We're coming to defeat you guys on Monday, so I can't have class on Monday. Why is okay? I'm now the host, I think.
Tuesday.
Now we'll learn today.
Yes, we still have it now.
I haven't even said my lesson. Ok. Bon, alors on va commencer maintenant. Okay. So I was asking, I hope you're able to see the screen.
Yes, we're able to see.
How do you think you can solve for this question here? What comes in your mind to say, if I say résoudre d'un R l'équation, what do you think we should do here? What is coming to your mind?
I think we're supposed to solve it.
Sorry?
I'm thinking of finding the solutions for X. Now, since you said in Analyse, we don't usually find the exact values. We write those values in form of
Voila, c'est ça le principe. But attention, I didn't say we don't find values. I didn't say that. I said normally we have expressions. Okay, we have expressions. Hey, can you stop talking about knocking off? Eh? We are doing questions here. Ruben, stop talking about knocking off. Bon, we have x squared is equal to x plus 1. So what do we do? If I say result greater than r, mean that you should solve this expression in r. In r, that is saying, I'm just saying you solve or find the values of x. Okay, find the values of x in real numbers. Okay, that's what I'm trying to say here. So what do you do if I was to say find the values of x here? Very, very simple. You come and say x squared. This is a polynomial function. So this x comes this side, you're going to have 1 minus x minus 1, which is equal to 0. Okay. So already, if you have this equation, you cannot have sum product factor normally, but you have the sum, you have the product, but the factors are going to be very, very difficult for you. So what do? You use delta. So find for me the values of delta. What's the value of delta you can find? Value of delta is what?
5.
No, it can't be 5.
5.
Delta can be 5. Are you sure? Because delta, we have delta is equal to square root of b squared minus 4ac, n'est-ce pas? So our delta, this is our a.
And so I kind of asking if you could repeat, we had some connection problems.
Okay, so we are solving this question. The first
Ernest, I meant root 5. Sorry. Root 5.
Yeah, root 5. Root 5 is correct. Okay. Bon, for this, the someone said that they had connection problem. So I was saying now we are finding this equation. Bon, let me just write everything now. Okay, so we are finding, if I say résoudre dans R l'équation E qui est égale à x au carré égale à x plus 1. Here, what I'm trying to say is find the values of x. So this is a polynomial, isn't it? So I'm going to have x squared is equal to x plus 1. Okay, and this implies that we'll take all these forms to this other side. We're going to have x squared minus x minus 1, which is equal to 0. So we have got a sum, we've got a product, but the factors are going to be very, very difficult. So what do we use? We use the delta rule. So we find delta. So we know that delta is equal to square root of b squared minus 4ac. Okay, we all know this form, no? If you should tell to say, I don't know where that is coming from. Okay, so that we can move at the same rate. Okay, so we have our a, we have our b, and we have our c. Okay, so we find delta, we're going to have square root. B squared is -1, so we're going to have -1 squared minus 4. Our a that we are having is 1 times our c, which is -1. Voila, we're going to have this. So square -1 to the power 2 is 1. -4 times 1 is 4. -4 times -1 is +4. So we're going to have delta. Delta is equal to square root of 5. Est-ce que c'est bon jusqu'à maintenant? Are we okay there?
Oui.
Oui.
Alors, qu'est-ce qu'on va faire maintenant? To find the values of x, we have the general formula negative b, positive or negative delta over 2a. So we find x when x is positive. Negative b that we are having is what? Is negative 1, n'est-ce pas? B is negative 1. So negative times negative, we're going to have 1 plus delta, which is square root of 5, over 2 times a. A is 1. So 2 times a, which is over 2. And that's the first value of x. And the second value of x, when it's less or negative, we're going to have la même chose, 1. The sign changes, we're going to use minus. Delta is square root of 5 over, what do we have? 2 times 1 is equal to 2. So those are your two values. So I've got 1, x1, and the x2. And you have solved the first question. Do you have any problems there? Vous avez des questions là-bas?
Mr. Ernest. Hello?
Yes, I can get you.
Yeah, so does it mean that this question has got nothing to do with suites? It's just a quadratic equation?
Quadratic equation. Just put, yeah, just to help you guys. It's a quadratic equation.
So what's the possibility of us having factors when we're given a question like this one?
You have to search. You have to search. You use the same. If the question had factors, the probability is high. It can be there. Okay.
Yeah.
If that depends if the quadratic equation that you've been given. But in this case, the quadratic equation that you've been given, you don't have factors, so use the delta row. Okay. But if you have factors, you can use the factors and find the original values of x and x1 and x2.
Well, so it means that there are times where we can have factors.
Yes, yes. Ça dépend juste avec it will depend the equation.
D'accord.
Okay. Est-ce qu'il y a quelqu'un avec la question ici? Is it clear? Because we're going to use the whole question is almost the whole question is going to be based on what we have solved here. So if you're not clear, you should tell me. Is it okay? Free mark, eh?
I just have a question. But in those two suites, like we're going to use them in these other questions, right?
Oui, bien sûr, bien sûr. Attends, juste maintenant, on est juste pour cette question. In this, we are just solving this question for now. So I'm asking, is this question okay? Are you able to find answers?
And also, Mr. Ernest.
Oui?
So in an instance where you're solving this question, are you obliged to always show delta, or you can just go direct with the whole formula?
You can go direct to just the whole formula, but normally I would prefer you use delta so that you show the steps. Math is about steps, so it's good if you tell the person show each and every step that you are solving.
Oh, d'accord.
Les filles, pas de questions. The girls, no question.
No.
Okay. So I can wrap this if you have already written the work. I hope you are writing, because I can forget to send you the answers, and if you didn't write anything, that's a lot difficult. Okay. And when I told you yesterday to say just solve one question out of them, you couldn't even solve this one, guys. Huh? Ruben.
Yeah, as in I've solved the number. I think as if.
Huh? Someone was saying.
We're thinking it was related to the suite somehow. So I thought maybe we had to put in some things like Analyse just to bring a question like this. We thought maybe it is impossible.
Actually, profs even give you questions like this, and somebody is going to tell you this is how you solve this question. You'll be like, no, it's a lie. That can be the way you solve it. Like, no, this is how I can solve this question. Like, no, this is analysis. Analysis is simple. Analysis is very, very simple. It's just about you playing smart. It's about a game of smart. Analysis is about being smart. So if you're smart, you're able to get the stuff. Somebody will solve it in a complicated way, but as long as you're smart and you know where you have to touch, you solve it. Okay. So question 2, we have soit alpha and beta les racines de l'équation. So we have alpha and beta. And we are told that these two are the racines. If I say racines of the equation, what do I mean? Ça veut dire quoi?
Factors.
Okay, so if they are factors, mean that the original values of what? Of x that I found, isn't it?
Yes, yes.
Of which equation? Of this equation, equation E, which is this equation that you have here, such that alpha is greater than beta. N'est-ce pas? So if we say, remember the equation that we had x1 was equal to 1 plus square root of 5 over 2, and x2 was equal to 1 minus square root of 5 over 2. So if we say alpha is greater than b, which of these is alpha?
The first one.
X1. The
So
first
this is equal to alpha, and this one is equal to beta. Do you now see how they have connected question 2 and question 1? That's how it comes in the exam. So they've connected this, what you found here, to this. Undone Tn. So now we've been given a suite Tn, which is equal to suite Un minus alpha over suite Un minus beta. Show that Tn est une suite géométrique à caractériser. So we show that this suite Un is a suite géométrique à caractériser. So it has got characteristics of a suite géométrique. What's the general formula that you had for suite géométrique? It was equal to what? Oui. For example, we use Tn. So if it's just geometric, you are going to say Tn plus 1 is equal to what? Bon. It's equal to, if I may do, you have forgotten already, you just learned this.
Isn't it equal to T0 multiplied by a to the power 0?
Pardon?
The general the equation which we got, it was Un is equals to U0 times a to the power 0. So in this case, since we're dealing with Tn, sorry, to the power. So in this case, since we're dealing with Tn, it's so Tn plus 1 is equals to I think T0 times, I really don't know what will take up the a, but a to the power n, which is, I don't know, I'm not really sure.
It's the same principle. It's the same principle of me using Tn plus 1. We can just use Tn is equal to T0 being your first term times Q, which is your common ratio, to the power n, which is the nth term. Okay. So you already have this as a general formula that you're going to be having to show that the suite is geometric. Okay.
Oui.
Alors, qu'est-ce qu'on va faire maintenant? So we have been given Tn, which is equal to Un minus alpha over Un minus beta. So what's the first thing that comes to your mind? We have already posed that alpha is equal to this, and I've already posed that beta is equal to this. So we already have the values of alpha and we already have the values of beta. Okay. Alors, so if we want to prove that the suite Tn is suite geometric, meaning that we have been given Tn as a first term. We have to look at it, what form are we going to use for Tn plus 1, so that it can help us find what? It can help us find the Q, okay? Or it can help us find the common ratio, okay? So for you to find, you have to find the common ratio between Tn and Tn plus 1. So if you have Tn is equal to this will mean that Tn plus 1 will be equal to what? If you have Tn is equal to Un minus alpha over Un minus beta, then Tn plus 1 will be equal to what? A girl to say before a point. Kerikan, a girl. I would want a girl. The girls have been quiet. Mulenga, wait. What do you think here?
I'm not so sure.
Bon, okay, look at this. If Tn is equal to Un minus alpha over Un minus beta, what if we put En plus 1 here? What are you going to have here? What's going to change? Only Un and Un are going to change. Okay, so we're going to have Un. There's an increment in the n function. So we're going to have, if it's an increment to the n function, I'm going to have also Un plus 1 minus alpha over Un plus 1 minus beta. Est-ce que c'est clair? Are you okay now?
Can you kindly no.
Look at it.
You said there'll be an increment?
Yes, we have Tn. Tn function that you have here is Un minus alpha over Un minus beta. So if we say Tn plus 1, mean that it's an increment of the nth term, isn't it?
Yes.
So if n plus 1 here, this is the n, this n and this n and this n are the same. So if we have an increase here, this n should increase, this n should increase, isn't it?
Oh,
whatever
okay.
I do also be the same at the right hand side. C'est ça la mathématique. So if we have an increment plus 1, mean that this switch Un is going to increase, this switch Un is going to increase. That is why we have this. Okay.
Answer the question. But why are we adding plus 1?
We are adding plus 1. We want to show that this switch that we have here is switch geometric. But for it to show that this switch is geometric, you have to find the value. We have the general formula. Tn is equal to T0 times Q to the power n. So we are finding Q, which is a common ratio. And how do you find Q? The Q that Q can only find the Q that we're having here is we want to find Tn plus 1. Normally in Zambia we used to say the second term divided by the first term. Okay, so we're trying to find the common ratio between Tn and Tn plus 1. That is why we're having Tn plus 1, which is equal to Un plus 1 minus alpha over Un plus 1 minus beta. Okay, so we're finding Q, the common ratio. Est-ce que c'est clair?
Okay, c'est clair.
No other question? Everyone is clear on this point?
Oui.
Okay. So if we have Tn plus 1 minus alpha over Un plus 1 minus beta. Alors, qu'est-ce qu'on va faire? Un plus 1 has already been given. Where is it? It's here. Un plus 1 is this one here. So we're going to replace Un plus 1. We're going to have 1 plus 1 over Un over Un plus 1 is this one that has been given here. 1 plus 1 over Un minus alpha over minus beta. Solve this. First. Solve this part on top. What is it going to give you? The top part, you have one. Huh? You want us to solve together this part? No. I just fail on some. I'm going to have problem.
Kindly that part. I didn't get how you write it.
un into this one is un times this one. We're going to have un into this one is 1, so I'm going to have plus 1 minus alpha over, c'est la même chose qu'on va faire. We're going to have un plus 1 minus beta. So we solve for these two. We're going to have un into un is 1. We're going to have un plus 1 minus alpha un over the same thing. We're going to have un plus 1 minus beta un over un. Okay.
Kindly repeat from the previous step.
The
second equal sign. I didn't get how you write that part.
Here you have your denominator here. So
you 1 over 1 plus 1 over un minus alpha.
Minus alpha un. Un into 1 into un is un times alpha is alpha un.
Above that.
Above this here.
Yes, right there. How you arrived at
here you have here I've got tn plus 1 is equal to un plus 1. Un plus 1 is this here. You can see it. It's what I've written here. I've just replaced this un plus 1. So un plus 1 is equal to this, the suite, and I've put it here, and un plus 1 which is equal to here. I've also replaced with the suite, which is here. And I've solved this fraction that is on top, and the fraction that is down, which is here. Okay.
Right.
Bon. After all the calculations that you guys bon, c'est avec faire, you can try to do it on your free time. So I'm just going to go there to the answer. So I mean, these are just fraction that we should do back home. So it's not something very, very complicated. So we're going to find Tn plus 1. After you solve everything here, bon, we're going to have 1 plus beta un over 1 plus alpha un. Okay, so that is it, Tn plus 1. So Tn plus 1 will be equal to 1 plus beta un over 1 plus alpha un. Est-ce que c'est bon jusqu'à maintenant? Oui, question?
Enes, can you please start from Tn plus, okay, no. Okay, good point. Okay, can I draw on the screen?
Oui, oui.
Okay, starting from here.
But you understand more?
Yeah.
Together from here. Like people are having problems from here.
You lost me just when you said that.
Pardon? You can as well be trying out. You can try out on a rough piece of paper so that you can understand well. So I'm going to get this up part here, just this part that is on top. We have 1 plus 1 over un. minus alpha. Okay, so I'm going to solve this to make it one fraction. So how do I solve this? Solving fractions, we're going to have this. What's the the denominator here? What denominator are we going to use? We're going to use un. So un, 1 into un is un times 1. It's going to give you un. Un into un is 1 times 1 plus 1. Okay, c'est ça qui est ici. Alors, minus alpha. Are we okay there? Is that part okay?
Yes.
Same thing here. We're going to solve this again as a common fraction. We're going to use un as a common denominator. Un into un is 1. So we're going to say 1 times everything. We're going to have un plus 1 minus 1 into un is un times alpha. It will be alpha un. So it's a function that we're having on top. Okay. If we want, we can dissolve this function that we're having here. We can say we put like terms together. We're going to have un minus alpha plus 1. Bon, un, sorry. Plus 1 over un. This can come here. So we factorize this part here. We're going to have un outside. We're going to have 1. Un into un is 1 minus un into alpha un. We're going to have alpha plus 1. Everything over un. Okay. Can you write this down? Write it down because I'm going to wrap everything and then I solve for the down part. Somebody can write this down. Has someone written this part? You should tell me in case I forget. Has someone written this part?
Yes.
So is the up part okay? The up part, is it okay? Pas de question pour the up part, n'est-ce pas?
Oui.
So for the down part, we have 1 plus 1 over un minus beta. C'est la même chose qu'on a fait ici. C'est la même chose. Minus beta here. Un. We have 1 there. We're going to have un. This into this plus 1. C'est la même chose. Over 1 here. I'm going to have un plus 1 minus beta un. To factorize, c'est la même chose qu'on a fait ici. We're going to have un open bracket 1 minus beta plus 1 over un. Est-ce que c'est bon maintenant? Bon. You have to tell me right now, not after I explain any like, oh no, I didn't understand there. So if you're not clear somewhere, send me for maybe because yes, you still have a little kind of a long way to go. I don't want to make anybody lost at this point. Okay, so we have found the common functions that we are having, our common numerator and our common denominator. Okay. Après ça, ça sera maintenant très facile à simplifier ça. So we have un on top, un 1 minus alpha plus 1 over un over un minus beta. Bon, donc ça, 1 here plus 1 over un. Bon, after this, we're able to simplify this and this. We're able to say un 1 minus alpha plus 1 over un times. We simplify this part here that is down. I'm going to have un over un 1 minus beta plus 1. And voila, we cancel this, we cancel that. Okay. Donc, est-ce que vous avez des questions jusqu'à maintenant? Very quiet. So I don't know if you're understanding or. Okay.
But Ernest, the final answer that you have given, is it? How is the beta coming on top there on your final answer?
Attends. Okay. So we'll continue from here. We're going to have un. Oh, no space right here. Okay. Un 1 minus alpha plus 1 all over un 1 minus beta plus 1. Et voilà. Donc ici, we can try to simplify this part. We can say, bon, si on a ça fois ça, c'est la même chose. Bon, même si on a même compliqué beaucoup de choses ici, because it has been very, very easy. You just solve it from here, because this is going to complicate things. Bon, on va faire comme ça. Because here is going to start complicating a lot of things. You're going to have to start dissolving the UN function. And ça sera beaucoup plus compliqué pour vous. Bon, let's try to just take it from here. Okay, just from here. This same point that we have here. Where we have 1 plus 1 over un minus alpha over 1 plus 1 over un minus beta. We'll try to just take it from here. This is, well, normally if you simplify this up to the end, it's going to give you to be the same value it's going to give you, and just simplify from here. For example, see on this, this is the same as saying 1 over un plus open bracket 1 minus alpha over 1 over un plus close bracket, bon, open bracket 1 minus beta. N'est-ce pas? Est-ce que c'est bon? This and this, I guess we did in this form. Mais c'est rien changé. I hope you're okay there.
Oh, yes.
Même si tu simplifies ça normalement, ça doit te donner la même, because we're going to have over un here. We simplify, we're going to have un, which is the same un, and this alpha that is here. We have 1 over un. Bon, ça sera la même chose avec ça. Ça sera la même chose avec ça. Pardon. Ça sera la même chose avec ça.
We're unable to teach you.
Posta moderando.
Prof, your mic is on mute.
Pero eso envía nada más ahí.
I think he's trying.
I've been talking here, my mic was on mute. Hein? Désolé, je ne sais pas qu'est-ce qui se passe avec mon PC. I've been actually talking here. Why is my mic on mute? Bon, I have to explain everything now. Okay, désolé. I couldn't get you because my PC, bon, is on mute. Okay. Bon, comme je viens de vous expliquer, I will just take it from here. So we're going to simplify this form that we have here, try to simplify it, and suppose give us the original form, which is ça aussi, we try to simplify it. So we're going to have un, so if we have un 1 plus un 1 minus alpha times un So you can simplify this down part. un 1 minus beta. Okay. On annulesa. Et si on peut annuler ça, bon, il y a un qui manque ici. I don't have one plus also here. This here. Donc, si on peut annuler ça, we can say 1, bon, un 1 minus alpha plus 1 un 1 minus beta plus 1. Okay. Bon, très bien. Mais ici, we have to study something here now. Bon, c'est la même chose qu'on a pris ici. So here we have got un 1 minus alpha plus 1 over un 1 minus beta plus 1. Okay. We are going to turn up. If we can notice, on a quelque chose qui est très important ici. We already know the general function of what alpha is. We already know the general form of what our beta is. But do we know un? Un is a known because that's the general function that we're trying to find for tn plus 1. And we don't really know what our second un function is going to also be. Alors, qu'est-ce qu'on va faire maintenant? We're going to say un, the un function that we are having, we've already been figured out to say un plus 1 is equal to 1 plus 1 over n. Ça veut dire que on va annuler ça. Attends, on peut annuler ça, déjà. C'est impossible. So we can dissolve this function that we are having on top, and we're going to put it in a simple expression. Okay, we're going to try to put it in a simple expression such that when we interchange these two functions here, si on trouve par exemple le contraire, we find the contrary because one that we have in here is the difference that we have in here is the fact that on the up part, on the top part, we're having our alpha, and the down part that we're having our beta. So if we try, for example, we try to dissolve the two functions that we're having by us saying we multiply the up part by 1 over un, et c'est la même chose qu'on va faire down, on the down part. We're going to have 1 minus alpha plus 1 over un over, we multiply also the down part, we're going to have 1 minus beta plus 1 over un, which is exactly leading us to the normal function that we are having on top. Alors, we ain't having a positive value for the alpha because in actual sense we are saying our alpha that we should be having normalement c'est positif parce qu'on a trouvé que alpha c'était une value positive, donc ça ne peut pas être négatif, c'est impossible. C'est la même chose avec la value de beta. We having bon, normalement, bon, for beta we can still have a positive value, but if we have, for example, u0 and we have 1 over 1, ça ne sera pas indiqué ça. Alors, we're going to interchange these two. So how do you get to interchange these two? You multiply them by their contrary. It's something that we call when you look at limits. Par exemple, si vous avez une value qui est comme ça, x for example 2 over x, what do? You multiply this by the opposite of what you're going to be having. Bon, maybe also here you have a function minus x So you multiply this by the opposite of the function that you're going to be having. C'est la même chose qu'on va faire ici. We're going to multiply this by the normal function, the opposite function that we're going to be having. So if we multiply this just like this, we multiply by this the opposite square of 1 minus alpha. And when we multiply that, we're going to have 1. Normalement, on va avoir 1 plus. Ça sera le contraire. Si c'est le contraire, même c'est la même chose ici. If we multiply this by the contrary of this, these two are going to interchange. Okay. These two are going to interchange because of multiplied by the contrary. So if we multiply that by the contrary, we're going to have 1 over un plus beta over 1 over un plus alpha. And if you are to solve these functions that we're going to be having, this is going to divide itself with that. We're going to have 1 plus beta un over 1 plus alpha un. Being your tn plus 1. Et voilà, bon, c'est la même chose qu'on a ici. Hein? Ça, qu'on a ici. Et voilà. So that's the next term that you're going to be having to find the function. The next, the Q, product, the common ratio Q that you are searching for. So we've just found the Tn function, Tn plus 1 function. We haven't gone into details. We haven't gone into details to say, okay, which part am I going to use now? It's just like you have been given Tn, le Tn c'est déjà donné, et on a déjà donné maintenant le Tn plus 1. Maintenant, qu'est-ce qui va se passer? We are now going to try to find the value, the original value of Q that we are having. Put into mind that we've been given the two what is. Pardon. We've been given the general formula that we're having. What is the general formula that we had for the geometric? We had the Tn is equal to T0. Pardon. T0 times Qn. Ça sera la même chose. On peut dire Tn plus 1 will be equal to Tn times Q. When you, because you don't know the constant value that you're going to be having, times Q. And your Tn has already been given. So if your Tn has already been given,
hello, Ernest. Can you kindly repeat starting from where the UN were supposed to cancel and then you introduce the multiplication?
Where? Which part? You can try to write.
Where you introduced is the multiplication, because here in the actual sense the UN were supposed to cancel. Then this last part here, the last part here, these were supposed to cancel. Can you explain from here how you came up with, how you went about it here?
Well, you're saying the UN is supposed to cancel.
No, I'm saying I'm lost from here, where you introduced something from here, because here where it's saying UN open brackets 1 minus beta.
Where?
From here down, come down here where you're written.
Bon, you see, Alasho, try to write using your phone. Second for me, like, okay, set practice it.
This
okay,
this part was supposed to cancel, right?
Attends. No, this was before Nespa. This was after here when I was trying to solve it. This is a different part. I was solving here. May we? Quelle est la question ici? You can't cancel this part because you're having two different functions here. You have 1 minus alpha over 1 minus beta. So you can't cancel the UN. Plus you still have this one, a plus 1 here, and over plus 1 there. So you can't cancel it.
All right, continue. Yes, continue from here. How you came up with the rest.
Here I said you have, I'll start from here. You have 1 minus alpha plus 1 over un over 1 minus beta plus 1 over un. So you find their general form. So like I said, from the previous question that you're having, we're saying alpha is greater than b, and the alpha that you're having, we said we found was a positive value in a span. So in actual sense, if you have 1 minus alpha, mean that you're going to be having a negative, this suite that you're going to be having is going to be a negative value of a. Okay, so I said for you to dissolve it, you're going to use the contrapose. The contrapose, well, it's just the way that has gone that we normally use yeah, but you can just say a contrapose, it's just the opposite. So I said you multiply by the opposite of 1 plus alpha. And the same thing that you do on top, the same thing that you do the contrapose of 1 minus beta. So if you do that, you're going to, for example, vous avez A plus beta, you see, the même chose. You're going to simplify the down part, and you're going to also simplify the up part. You interchange the two, as you're going to be simplifying the down part. Si tu fais ça avec, bon, à ton temps comme ça, you're going to find everything that I'm talking about here. You're going to find 1 plus bun over 1 plus un. So the first thing is find the contrapose of this and find the contrapose of that. Après ça, you interchange them, or if you don't want to interchange them, just simplify them down here. You simplify it down that side. It's going to give you 1 plus bun over 1 plus un, which is a common tn plus 1 that we're actually looking for. So let's find the contrapose of 1 plus minus alpha and 1 minus beta. The juicer, the packet which is but can you try to rub on the personal throat on the right thing? Hello? Oui. Okay. But did you tell the guys that don't be having class on Monday? Yeah. All right. I hope so. Yeah, I'll be done. I think that's solved the question I'm solving, and then I said yeah. Yeah.
Ennett,
Okay.
next time we have the TD, do you mind writing on a paper? Because like this, I don't know if it's just me, but I find it hard to follow because everything looks joined. Like it's hard to...
All right. Oui, c'est pas grave. C'est pas grave. Je vais faire juste comme ça. C'est pas grave. Ok. C'est bon. Alors, je vais faire juste comme ça. Alors, bon. Comme on a ici, we have Tn plus 1, which is equal to Tn minus Q. Pardon. Minus times. Okay. What is the Tn? Tn that we're having is what? Tn that we're having is Un minus alpha over Un minus beta. So I'm going to say Tn is equal to Un minus alpha over Un minus beta times your Q. And Tn plus 1 is equal to 1 plus beta Un over 1 plus alpha Un. Okay. After this, what can we do? We can actually cross multiply here. We can have 1 plus beta Un times this part that we have there, Un minus beta, which is equal to Q, the Q that you have in here, Un minus alpha, open there, times 1 plus alpha Un. 1 plus alpha Un. And voila. You simplify this. Try to simplify this for me. This side.
Mr. Ernest. Hello.
No, it's gone off.
I think it's okay. So the part where you've written Tn plus 1 is equal to Tn multiplied by Q. That since Tn before the equal sign has increased by 1, isn't Tn on the other side supposed to increase by 1? But then you've only written.
No, this is a general formula. It's a general formula that I'm using. I'm using the general formula. The general formula for switch geometric is Tn for the next term. If you have to find the next term, it's equal to Tn plus 1, which is equal to Tn times Q. That's the general formula. So I'm just replacing what the general formula has given to me. Okay.
So the n on the other side, like after the.
Then increase, because if it increases, it's going to be equal to this. It's a Tn plus 1. It's a suite. Okay. So for the suite, for the next, if you want to find, for example, Tn is equal to T0 times Q. Okay. But Tn plus 1 is equal to Tn times Q. That's the formula for switch geometric for the next term. Est-ce que c'est bon?
Oui.
Yeah. Has someone simplified? Bon. Just there. Okay. On peut faire la même. So we're going to have 1 times Un. We're going to have Un. 1 times this, we're going to have minus beta. So beta Un times Un, we're going to have plus beta Un squared. Beta Un times negative beta, we're going to have minus beta squared Un, which is equal to QUn times 1. We're going to have un QUN times alpha UN, we're going to have plus Q alpha UN Q times Q negative Q alpha times 1, we're going to have negative Q alpha negative Q alpha times this, we're going to have negative Q alpha squared. Oh, this one times this one is supposed to have squared here. Yeah. This was squared. And we're going to have alpha UN squared. Très bien. Voilà. Ça, maintenant. Alors, qu'est-ce qu'on va faire maintenant? We're going to put like terms together. So I've got the ones with UN squared here. Here, just in the color. Very, very simple. UN squared and UN squared. I've got beta squared. I've got alpha squared. I've got UN. I've got UN. Here, you see. And if we're able to simplify everything, we can have bon, we're going to have beta UN squared plus so 1 minus beta and UN minus beta beta. These are the main shows. We simplify for this other side. I don't have Q UN. I hope people are simplifying, but I'm also trying to simplify here. UN alpha QUN squared alpha QUN squared minus alpha Q minus alpha squared QUN. Ok. Est-ce que c'est bon? Bon, vous avez resté tranquille. Est-ce que c'est bon?
No
Problème.
Mr. Ernest, I have a question on how you were multiplying Q. Was it not just supposed to multiply with the one thing which was in the bracket? Now you multiplied it with everything.
No, Q only multiplied with the top part here. It only multiplied with UN minus alpha. That's one that I multiplied with Q. Okay.
Oh yeah.
And then everything here multiplied with this here, because I cross multiplied.
Yeah.
Okay. So we are now, bon, with this part that we have written here, now it's going to be very, very easy for us because we are just going to use the general mathematics that we had from back home, where we say, but if we simplify everything here, we're going to have beta UN squared plus 1 minus beta squared un minus beta, which is equal to alpha q squared plus q minus alpha squared q un minus alpha q. Très bien. Alors, from the back mathematic corner, what is our value of for alpha? In this case that we're having. Look at this. We have beta un squared.
Ernest, we are asking if you can be writing on a piece of paper.
Oui, j'ai oui. I said yes. The next time I said this are déjà oui.
Oh, right now you don't have?
Right now. Because normally
Okay,
I just when like what I'm doing like this. Yes, I make questions, but normally the solution is when I'm solving it right now. So I'd have to sit down and solve them, and then I make it what you say. I make a PDF or something. Okay. So we have beta un squared plus 1 minus beta squared un minus beta, which is equal to alpha qun squared. So what do we do here? Polynomials, the rule of polynomials. Yes, we did some part of polynomials when we were back home, where we have un squared and un squared, they have got the same powers. Ça veut dire quoi? Ça veut dire que beta is equal to alpha q. Okay. You can see we've got the same powers, un squared and un squared. So this is identical to this. Après ça, you can also have 1 minus beta squared, which is here, and we've got 1 minus alpha, bon, that is q. If you simplify q, we're going to have the same stuff. Ça veut dire que ça, you can also have 1 minus beta squared is equal to q. Here we can easily factorize it. We're going to have q. We're going to have q 1 minus alpha squared, which is the second equation that we are going to be having. Okay, and this is equivalent to us saying negative beta is equal to, simplify this is going to go this side. We're going to have a q, decompose this. We're going to have a negative b minus alpha q. You simplify this, negative 1, simplify this, negative 1, cancel that. We're going to have beta, which is equal to alpha q. La même chose qu'on a ici. Alors, this form that we have in there is correct. So if we have a form that we have in there is correct, ça veut dire que q automatically becomes to beta over alpha. Beta over alpha. So the value of q is beta over alpha. And voila, you've managed to have your equations. Of course, you can be able to simplify your value of beta.
Ernest, I've got a question. So all these equations are just to find q.
Oui, c'est ça. We've been trying to find q. Like I said there, I took note of it here. I said we need to find the value of q. Okay, that's the only way we can find we can show that the suite is geometric. So when you find the value of Q, that's when you can now start posing in some things. So at the moment, we're able to finally find the value of Q. C'est ça, mais c'est vraiment simple, n'est-ce pas? Vraiment simple.
So I've got another question. As in, are we trying to find an expression of Q or trying to find the exact value of Q?
Well, no, bon, in this case, we don't have numbers, but of course, since you already have beta, you already have alpha, you're able to replace, you can replace your beta, or if you want, you can replace your alpha. You're able to find a digit, but even if you are to leave it, for example, in this form, c'est pas grave.
So in other words, we've already calculated for Q. That is Q is equal to that expression there.
Maintenant, I don't know if I got your question.
As in, so that means if we are to follow through, that means that is our Q there, or are we still heading on the finding of Q?
Here we've only found it. I've only found in this form B is equal to Q alpha times Q. So we try out in a form, the second form that we had here, 1 minus beta squared is equal to Q 1 minus alpha. So that's the second part. We have to also show the value of Q that we're going to be having in a scenario like this. So for example, here we have 1 minus beta squared, which is equal to Q minus 1 minus alpha squared. In this sense, we're going to have Q, which is equal to 1 minus beta squared over 1 minus alpha squared. Okay, so we have a Q again. So I've got Q beta over alpha, and we've got Q 1 minus alpha squared, beta squared over 1 minus alpha squared. And after that, now this one we can actually get to replace the original values that we had for example, for Q. And in actual sense, when you simplify this part here, it's going to get you back to this. Okay, if I to, for example, replace every value that is here, it's going to get us back to this. On va voir ça, vous allez voir. Alors, on va dire 1 minus, what was the value for beta? Beta value that we had was 1 minus square root of 5 over 2. Okay. Oh, I've solved a lot. Bon, c'est pas beaucoup. C'est pas beaucoup. Just a few. Over 2 over 1 minus 1 plus square root of 5 over 2. So in actual sense, this part here, Q, for example here, your Q is already this, because your beta is equal to 1 minus square root of 5 over 2 over this, which is your alpha, 1 plus square root of 5 over 2. Okay, so this is what you have here. So we're also going to prove that the second Q function that you're having for Q, because you're supposed to prove, you just can't come here and say, okay, this is my original function. You still have function that can help you actually get to prove that Q is equal to beta over alpha. Or the possible value I'm going to be having for this is actually similar to what I'm going to be having when I use another part of my polynomial. Okay, so I'm going to say Q here is equal to 1 minus 1, negative times negative is going to be positive, plus square root of 5 all over 2. Okay, la même chose qu'on va avoir ici. Bon, attention ici, ça sera comme ça. I won't have the 2 here because we have to solve this function that we have on top. La même chose qu'on va avoir ici, 2, everything, 2 minus 1 minus square root of 5. Okay. And after that, we simplify. 2 minus 1 is what? Is 1. 1 plus square root of 5 all over 2 over 2 minus 1 is the same thing. 1 minus square root of 5 over 2. Et voilà. So you see, this is actually the same with that. So alors, you can find the original digits for Q, and that becomes your final answer for the function Q, or for your common ratio Q. Okay.
I have a question.
Oui.
So, is it obligatory that you need to find another expression of Q, or did you just do this just to prove that it will give the same values?
It's obligatory because sometimes you can, if for example you made an error here, you see, if you made an error here in the calculations and you find the form, it gives you something different to this. This one's just like, it shows that you have done the perfect way. Okay, because maybe this is mathematics, so you can maybe make an error here. So if you make an error here without you help showing this part here, you can get the answer wrong or the response wrong. Sometimes a question like this in an exam maybe can be, well, normally more like this question, they'll give you like maybe 2 marks. Okay, if they give you 2 marks, if you don't show that part, maybe just give you 1.5. Okay, so I haven't proved to the prof like, okay, genuinely speaking, this is my answer. Because sometimes the prof can make a mistake, can make an error and find a certain value. But if you prove all the 2 parts, this part and this part is okay, surface, c'est bon pour toi. Okay, so it's very, very essential that you show also the second part, you prove the second part that the value you're going to be getting is correct. So with this conclusion, we can say that T is a sweet geometric. Why? Because it's got a common ratio of this form 1 minus square root of 5 over 1 plus square root of 5. And voila, you've solved the question. Very, very simple. Wow. C'est ça qu'on fait la question pour ça. So that was the answer for, that's how we show that the sweet TN, a sweet geometric, just by you proving that K is into a form of a fraction. Also giving you the next term, for you to find the next term, supposed to be like a division. That's the same that we used to do in Zambia. In Zambia, our Q, if it gives you maybe 2 over 3, c'est la même chose, c'est la même principe. Okay. Donc c'est ça. That's how you solve for question 2. Bon, we are very, very slow today. Hein? Very, very slow. We just done 2 questions. Okay. Est-ce que vous avez des questions? Was it a little bit tricky? Yeah, it was tricky. May, I'll tell you something. This is an exam question. Huh? This is an exam question. So I actually understand you. Now I said the TD that we're going to do next is, that's now the real TD now. This is the real analysis now. So yeah, they give you 1 hour, 30 minutes normally to solve 4 questions. Maximum is 1 hour 45 minutes to solve for all questions. So then you're in that environment now, and this is now the real analysis. Not I was saying that's where you're going to start solving. Donc c'est ça. Oui, que?
Oui, il y a une question. So when we solve for Q, is that how we show that it's sweet geometric?
Just you finding the value of Q is enough, because you're going to show that Q is in the form of a quotient, and it's a work done for you. Okay.
Oui, oui.
Okay. Yeah, but I know it was kind of tricky, yeah. It was kind of tricky at I rest assured, but it's an exam standard. So yeah, all these questions that I gave you, all these questions, these are exam standard questions.
So,
So
Mr. Ene, but you said that question carries 2 marks.
yeah, normally, because this is direct. Normally, it's 2 marks normally. Yeah, like for
Like out
example,
of 20.
no. Bon, normally, for example, like this question, maybe if it suits, analyze one is out of 20. So if you have out of 20, so in analyze one, you have got 4 topics. You have got suites, you've got functions, you've got development limited, you've got integration. No, pardon, derivatives. Okay, so it's like 5 marks, 5 marks, 5 marks, 5 marks. But normally suites carry 6 marks. Okay, so if it's a professor, the way they divide the marks, bon, like for example, this question is very simple. So here I just give you 1 mark. Experimental function, maybe 2 marks here, maybe 1.5 here. So I've got 1, 2, 2.5, 4.5. Yeah, maybe here is also going to give you 1.5. Yeah, and it's up. You'll get your 6 marks.
So there's nothing like the way it was at the answer mark, method mark, like in high school.
Methods they follow. Methods they follow. You're going to go to school and you start using those things that they used to, the marking sheets. Okay, where we write our responses. Those people. There's one time, there's a professor I remember. I wasn't satisfied with my mark that he gave me, so I went there to do what we call reclamation. I told him I want to see my paper because I was very confident I couldn't get the marks that he had given me. When I went there, I actually also like, okay, these people, they don't really check. They check every bit. Even this point here, they check. He's even going, even say red pens there. Every point is essential. So for example, because in Analyse, they say it's kind of difficult for you to get a 20. So even if you're able to get a 20 and you just left a simple part, it's going to tell you, vous avez fait une erreur ici. Donc, vous n'êtes pas désolé. It's going to give you a less mark. They follow, Moroccans follow steps. So every step is essential. Yeah. So you have to follow every bit of step that I've. And why you're following those steps, you have to be explaining why you do this, why you do that. It's very essential to show the proofs that you have understood. Okay. And out. When you go to your schools,
Yeah, the first one tell
your schools, the secret person at university is this. It's not about how much you study. It's not about how much you attend class. I'll be very real with you there. There's some people that I've seen that have been studying from the time they went to school. They've been attending school like, I don't know. You sometimes wake up, you find them at school, you're leaving school, they're still at school. But the thing is this, when you want to validate at university, like Moroccan University or the French system, you have to play smart. How do you play smart? You have to know how your professor sets questions during the TD and how he responds. As long as you're able to get those two, trust me, you're going to validate modules. How you don't even know. Just study those 2 things. Study how the prof gives questions. Study on how he responds to questions during the TD. That's the secret. I don't have grades the professor. Okay, just go there and ask him. Okay, just ask him, talk to him, make him your friend. The guys, the profs are very friendly. Okay, just go there and talk to him. As you talk to him, he's going to be telling you, par exemple, dans l'examen, je vais vous donner une question comme ça. Take note of that. Those questions is going to bring. Okay, so it's about playing smart. University, there are people that are intelligent that are fraud at university. You see, so it's about you playing smart. As long as you're able to play smart, you're going to validate things at university. Are we okay? So it's the same thing with this question. Play smart. Play your cards. If you play your cards right here, you need to show everything here. But as long as you know how to play your cards, you're going to get 1.5 mark. Everything, you're going to get it. Trust me. Oui.
I also heard that when presenting your answers, you need to be writing words like donc, shani, and shani.
Very important.
that is we call that mathematical communication. Okay. I think when I sent I was responding donc, alors, on pause. Normally, the analyst profs, they like things like on pause ça, si ça, on peut dire ça, on peut déduire ça. Those are the things that are very, very essential when you're solving an analyst question. Like that, the profs will be very, very happy. Okay. So, never. So I know this question was kind of very, very complex for you. Yeah, you should try to go through it during the weekend, and the next time we meet, we're going to start exercise 3, and we are going to move comme ça. Ça, c'est s'il n'y a pas de questions. Was it difficult, the question?
No, we just need to follow the steps. I think most of us
But if you get the general concept, n'est-ce pas? At least you're able to get the general concept. So as you follow, you already know what you're doing. Yeah, are you?
Yeah, we're in lane.
Most important thing. I don't mind if you fail the answer, but as long as you're able to get the general concept, that's the most important thing for me. Yes, AQ. AQ wanted to say something. So your hand was up. Oui. Bon, c'est bon. Alors, s'il n'y a pas de questions, merci beaucoup. I'll send you the answer that you have solved for exercise 1 and exercise 2 in the group. For those that are supporting Madrid, we are going to win. Yeah, we are going to win today. And for the others that won't be supporting, it's so sad for you guys. It's going to be so difficult for you. Ok. Donc, on se verra la prochaine semaine, Inshallah. And in India, and the other guys are going to be coming in Kenitra.
Big man,
merci beaucoup.
Don't forget to send the picture of the last week, even what we've done so far, if possible.
Right. Yeah. Let me just look for that paper right now.
Mr. Ernest, you can also show all these writings which you are doing here, like for the answer which you are about to say.
Yes, everything is there. Okay.
All right.
Okay. Merci beaucoup. Hala Madrid.
That's it the other way.
Arab.